To create a new C# script, right-click in your project window and then go to Create in C# script. Let's name this Click Control. Basically, what this script is going to do is allow us to control where the visual effect is based on where we click with the mouse once we start the game. Now, the first thing we should do after creating the script is go to our visual effect in the hierarchy and then drag the script onto it. Next, we need to open the script for editing. To do that, simply double-click on the script and it will open up your editor. Now for me, I use Notepad++, but yours might pop up something like Mono Develop or Visual Studio. Either is fine as long as you're able to compile and execute your code. Now, here's where we start scripting. As a programming instructor, I understand it can get both complex and overwhelming for necromancers, newcomers, very quickly. And there's a lot to learn, so I've attached some notes for you to pause and read at your leisure. However, I'll do my best to keep it simple here and only discuss what's essential. Each word, each curly bracket is important, and structure, and when coding, is very important, except for comments, which are basically personal notes for you to read. So, to ensure this code works optimally, you must pay close attention. Writing or spelling something incorrectly will result in an error, and the code will not run, nor will the scene play until the error has been fixed. A syntax error is when you've written something wrong, so the code in Unity won't compile. A semantics error is when it compiles, but it doesn't do what you want it to do. Let's avoid both, and let's get started. Now the first thing we'll need is a new import statement using unityengine.vfx. This allows us to access the visual effect graph code. From there, we'll need two new variables, visual effect, and the variable name will be VFX, and camera, and the variable name will be cam. Think of variables like cups that hold data of specific types. Next, inside the start method, what we'll need is to use that variable to hold a value. And the value we're going to hold is a component, so get component, left and right angle brackets, left and right parentheses, semicolon. And the component we're grabbing is a visual effect that is attached to the same game object that this script is attached to. So if we click over here, visual effect, this click control script is attached to this visual effect, and so is this visual effect component. So this is the component that we're getting with this line of code. Next, we need to do the same thing with camera, or cam in this case. So cam equals camera.main. And so when we say camera.main, it finds the static camera class and returns the main camera in the scene, which in this case is this one right here. Next, the update method. Now, since the update runs multiple times per second, in fact once per frame, ideally, it's the perfect place to detect user input. Here, I've added some extra comments in green if you'd like a bit more understanding on the coding structures we're using. Now, using the update method to detect user input allows us to execute code when the player activates a button or mouse. An if statement allows us to decide when to run certain code blocks. Here, on line 42, we're detecting the first frame that the user presses the left mouse button down. And if they do press it, then we want to send a start event to the visual effects graph. Here, we make another if check for when the key is released. And if so, we call the stop event instead. This stops the VFX graph when we release the mouse button. These are called semicolons, by the way, and are placed at the end of a line of code to indicate that that's where the line stops. It doesn't go after if statements, or curly brackets usually, but it will come after most singular lines of code or variables. One more thing, these debug.log statements here allow you to print to your console in the Unity engine when certain sections of code are run. This is a basic yet incredibly useful tool for understanding, debugging, and fixing your code. Let's test it before we continue. Save your script using Ctrl+S or File, Save, then we can switch back to Unity. Here, an important note, when naming the events here, start or stop, ensure that there are no spaces at the end of the name or before it starts. Otherwise, your code will expect those same spaces when you call the event through your script. Ensure your graph is saved so you know the latest version of it is being used. And check your console tab for errors. If there are any errors with your script, they will show up here in red, and you must fix them before you can continue. Next, we have multiple tabs here, but what we want right now is to see the scene view and the game view side by side. So click on scene, then left click and hold on game, and drag it to the right until the square appears, then release to dock it. Now we have scene and game view side by side. Next, if our goal is to test our script and whether it works, assuming we're free of errors, what we need to do next is adjust the camera. So in order to do that, consider that we have two views. On the left, we have the scene view, which is the world, and on the right, we have the game view, which is what happens when you press play. To adjust the camera in game view, we can click on the main camera in the hierarchy, then go to its transform in the inspector, and raise the value on the y-axis. Now, as I do this, watch what happens in game view. Pull it back a little bit, and let's rotate it a little bit on the y-axis so we can look at it from an angle. Okay, so now maybe not the perfect view, but this is roughly how it's going to look when we actually start the game. Remember, game view, scene view. Maximize and play. Let's give it a try. So here we see that the fire start's already active. If I left click and then release it, it'll stop. And if I left click and hold again, it'll start. Stop and start. And then release again. One other thing you might not have noticed, in the console, because of the debug.logs, I know exactly when I started holding a button and then let it go. This is why debug statements are useful. They help you prove that your code is running and test that the timing is working as you expected. Okay, let's return to the script and add the mouse button hold functionality. At the bottom of the else statement, we're going to add an additional else if block. So else if, parentheses, and curly brackets, input dot get key keycode dot mouse 0. The only difference here is we use get key for hold detection instead of get key up for key release or get key down for key press. Inside the if statement's curly brackets, we'll need to make a ray cast into the scene. You can think of a ray as an invisible beam with a starting location and a direction to move in. And cam.screenPointToRay converts a position on our screen into a ray directed further into the screen. So when we say ray mouse beam equals cam.screenPointToRay, parentheses, semicolon, input.mouse position, you understand that we're using the mouse position and the camera position to create a ray into the game world. Now that we've made the ray, the next thing we want to do is make a ray cast. On line 53, if physics.raycast, parentheses, mouse theme, comma, out, raycast, hit info 100, followed by curly brackets for the if statement. This is when we actually fire the ray. Again, it's still invisible, so this firing is only for detection, not visuals. And by placing the raycast statement inside of an if statement, it will only run the code inside of that if statement if the raycast hits. When we fire the ray, we store information about the collision in a variable called hitInfo, which we're defining right here using these additional keywords. And if it hits something, we'll grab the point of impact as a vector3 and move our VFX game object to that location. This last number here, 100, it just controls how far we can fire the ray. Right now, it's set to a maximum of 100 units, though it will stop sooner if it collides with something. To move a location, inside the if statement, we'll put vector3 position equals hitInfo.point and transform dot position equals position, grabbing hit point from ray, moving the VFX. Let's do a quick test of what we've got so far. So if I left click and hold, it moves the VFX to the location of the click, and if I move the mouse while holding it down, it will follow the mouse. And if I let it go, it'll stop. Now, say that I don't like the offset, I can always come here, change this to 0, and do it again. But now it's too far in the ground. Let's try that one more time. Let's try 0.3. Oh yeah, that looks good. Hi! Seems like you finished another episode. If you enjoyed the content, please remember to like, subscribe, and share. And if you're looking for the link to the next video, if there is one, you can find it in the description below. Happy learning!